It's good to have you back. How are you? Here, we are going to multiply two functions. We have f of x is equal to x plus 1 over x minus 1, and g of x being 1 over x. When we multiply expressions like this, we know as rational expressions, we need to be reminded of the processes of multiplying fractions as well. Let's start with this notation. You have f g of x. This means we are to multiply f of x and g of x, and their representations are as follows. For f of x, you have x plus 1 over x minus 1. Take note that you're multiplying rational expressions, so make sure you add here parentheses. And you're going to multiply this with g of x, which is 1 over x. Don't forget that whenever you are going to multiply two fractions or two rational expressions, we simply multiply numerator to numerator and denominator to denominator. This would mean the product of our numerators would be the result when you multiply x plus 1 by 1. So you will have x plus 1 times 1, so it would not change its value. But our denominator will be expressed as x minus 1 times x, which will give us a result. Of course, we're going to distribute the x there. So you have x plus 1 over x squared minus x. Don't forget that you cannot do this because there are terms that are part of both numerators and denominators that are separated by addition and subtraction. Hence, we cannot use the cancellation law. This is the result for f g of x, which is also true if we have g of f of x. Because multiplication is commutative, you will end up with the same result. Commutative in a sense that you have the same result no matter which factor is to be multiplied first, because just like 1 times 2 and 2 times 1, they're just the same. However, for division of functions just like this, f over g of x, this is not the same as the result when we do it otherwise. But let's start with this and represent it with our result. This means we divide with our entire expression, and instead of making it in a fraction form, let me try doing things like this. You have x plus 1 over x minus 1. Instead of making fractions of a fraction, we are going to have it like this and use this symbol, the division symbol, and 1 over x. The reason for us doing this is that we can use here the keep, change, flip method when we divide fractions, which means we keep the first group of terms or first expression known as your dividend. We keep it as it is. Then instead of division, we change it to multiplication, and we flip the second fraction or second rational expression, or we reciprocate it. That's why we flip it. You have x over 1. This is what we mean by keep, change, flip method. And we'll end up with the result of multiplying x plus 1 by x. You will have x squared plus x to be divided by the result of your denominators, x minus 1. So one thing is for sure, when you divide rational expressions, instead of using it as division, we are actually having here rational expressions because those are our functions. You use the keep, change, flip method. You keep the dividend. You change the operation from division to multiplication, and you flip your divisor. As mentioned earlier, this is not the same as this expression since there's no commutativity for division. And if we're going to try it, you'll have 1 over x to be divided by the entire expression of f of x, which is x plus 1 over x minus 1. We don't have the same result. I'm just going to add parentheses here because what you're going to flip is your divisor. So 1 over x will stay as 1 over x to be multiplied now with the reciprocal of your divisor. So you have x minus 1 here, and you will have x plus 1 here. So our result for the quotient of our two functions, g and f, would be the product of numerators and product of denominators. You will have x minus 1 over the product of the denominators, x squared plus x. As mentioned, we have different results because there's no commutativity for division. By the way, I forgot to place here x, as this represents division of two functions. So these are the results using the two given functions already expressed as rational expressions. That's all for today. You're dismissed. And please do not forget to subscribe now.